Good day everyone, we are the group 2 and we will be tackling all about chapter 14, which is the communication channel technology. To formally introduce our group members, I present to you our very own consolidator, Mr. Al Andre B. Esclamado.
We are the group 2 and here are our group members. Starting with our group leader, we have Ana Mitsuginyuzo reporting for the overview of the whole chapter. Consolidator is me, Alan J. Esclamado. I will be reporting for the part of analog signaling. For the members, starting with Cindy Caddis, reporting for the fundamentals of signaling and part of analog signaling. Kimberly Cadora, reporting for the digital signaling and modems. Jen Eric Domine, reporting for transmission media and signaling methods. Jason Nicole Incidencia, reporting for the alternative technologies. Last but not the least, Jerome Neil Enriquez, reporting for the Wi-Fi and Bluetooth.
Thank you for the introduction, Mr. Andre Esclamado. This is once again Ana Mitsuginyuzo and I will be your first presenter and I'm gonna give you an overview about the whole chapter. Without further ado, let's start. Let's first begin by defining what is a communication channel. It is a medium used for transforming information from one network device to another. It consists of a network interface controller that places signal from sending node to the receiving node, and it is also termed as the communication medium. So a communication channel, by the way, is characterized by signaling transmission method, and these signals pass through a number of different channel links that have their own medium, signaling method, and channel characteristics that are connected by intermediate nodes consist of switches, routers, and other devices before it can reach the other end node. So as we can notice, the word node is redundant, right? So the word node or network node signifies the endpoints of communication or distribution points over a network that can receive, create, store, and send data along distributed routes. So basically, the communication channel is characterized by the transmission medium, the signaling method, the channel capacity or bandwidth, the directions of the message or the flow, and the noise, attenuation, and distortion factors. So we have here a diagram of a communication model and a multi-link channel connecting a tablet and a computer. So let's first observe the diagram below. So this example uses various combinations of media and signaling technologies to relay a web request from a tablet to a web server somewhere in the internet. So the data in this example originates in a tablet, is converted to an Ethernet-based Wi-Fi radio signal by NIC in the tablet, transmitted to a router, converted back to wired Ethernet and passed to a DSL modem, converted again and this time to a DSL format and then passed through various routers, backbone networks, and other internet devices until it is ultimately directed to a network within the web server. Some of these links will be wires, some are fiber optic cables, and perhaps even a microwave or satellite link along the way. So the data signals in this example take the form of radio waves, electrical pulses, and perhaps light pulses at various points along its journey. So next one, we have the types of signaling methods, the analog and the digital transmission. So analog transmission utilizes continuous varying waveform, while the digital utilizes two different values of electrical voltage, which makes it the opposite of the analog since it is non-continuous. These two will be further elaborated in the latter part of our report. So the choice of whether digital or analog transmission signaling depends upon a number of factors. Some media are suitable for one or the other. Where either is suitable, the choice is made on the basis of other factors such as noise characteristics, the application, the bandwidth requirements, and other uses for which the channel is to be shared. Next one, we have multiplexing. It is a technique that carries multiple messages over a channel simultaneously. It has two components, which is the first one, we have the time division multiplexing or TDM, which is commonly used for digital channels, and second, we have FDM or frequency division multiplexing, which is used for analog channels. So that will be all for my part, and you're on to the next reporter.
The fundamentals of signaling technology. From the word signaling, signal means an electromagnetic or electrical current that carries data from one system or network to another. It is a time-varying voltage that is also an electromagnetic wave carrying information, though it can take on other forms such as current. A representation of the signal shown as a function of time is called a waveform. If the signal is continuous, then it will be called as analog signal. If it is not continuous, it will be called as discrete signal and is usually called digital signal if it's a binary discrete signal. Analog and digital signals also have similarities in a way that they both have a frequency and amplitude, and are both used to convey a variety of information. If we recall in Chapter 4, it says there that it's often necessary to transform analog signal to digital signal and vice versa. The following will be discussed further later. Now let's talk about analog signaling. Analog signaling is any continuous signal representing some other quantity. Analog signals are commonly used in communication systems that convey voice, data, image, signal or video information using a continuous signal. Also, analog signaling is required for wireless media such as radio and sound, for wireless networking, for cellular use, and for other forms of wireless data communication. The basic unit of analog transmission is a sine wave. A sine wave is the fundamental waveform from which other waveforms may be generated. A sine wave has an amplitude, frequency, and period. The amplitude of a wave is the size of the pressure difference it causes. It is the maximum vertical distance reached in either direction from the center line of the wave. As a sine wave is symmetrical about its center line, the amplitude of the wave is half the peak-to-peak value. The frequency of a wave is how often the wave repeats itself. It is the number of times the sine wave goes through a complete cycle in the space of 1 second. It is usually measured in hertz and sometimes also called cycles per second. Then the period of a sine curve is the length of one cycle of the curve. It is the length of a single wave from center light to peak through the center to trough, then back to the center. In addition to the amplitude and frequency, it is possible to measure the position of a sine wave with respect to a reference sine wave. The difference measured in degrees is known as the phase of the sine wave. Phase difference, that is also called phase or phase shift, describes how much one sine wave is shifted relative to the other. Sine waves that are perfectly aligned peak to peak are called in phase. If one wave is shifted by half a wavelength or relative to the other, the throbs of one wave is aligned with peaks of the other, and the waves are called perfectly or completely out of phase. The spectrum of a sine wave is a single point at the frequency of the sine wave. The spectrum of white noise is a line covering all frequencies. Theoretically, a perfect sine wave has zero bandwidth regardless of its frequency. A bandwidth is a measure of a signal's deviation from a perfect sine wave and ability to carry information. A perfect sine wave contains no information at all since it never changes.
Good day, my name is Alandre Escamado, and this is just the continuation of the report of Miss Cadiz, which is the analog signaling. Electromagnetic waves use space as a medium, although many materials are near transparent to the wave at some frequencies. AM radio band waves will pass through reasonable thickness of solid stones, whereas FM radio band waves and cell phone signals are attenuated. Leaves and thick rain clouds can block a satellite TV signal. Light is made up of electromagnetic waves with frequencies in the region of 100,000 billion Hz. Materials that are not transparent can be used to guide or reflect a wave. Fiber optic cables maximizing the light at receiving end of the cable by guiding the light through cables. A sound made up of sine wave produces a single pure tone. Sine waves are used as carrier for the data that wish to transmit. To restore our original waveform that was used to modulate the carrier, we use the modulator or detector. An example of carrier's amplitude modulated by another analog signal is shown in figure 14.9. Note that amplitude modulation is symmetric by respecting the center of carrier sine wave. For digital signals, the carrier signals is modulated by only two possible values, the value representing a 0 and the value representing a 1. In this case, the value modulation technique is called amplitude shift keying or ASK, frequency shift keying or FSK, or phase shift keying or PSK. Example of each are shown in figure 14.10. Filtering can separate the different data signals at receiving end. This technique is called frequency division multiplexing or FDM. It can be used to carry numerous TV channels on a cable system, for example, or to provide multiple channels for wireless Ethernet or Wi-Fi and Bluetooth. Ultimately, it's used the bandwidth more effectively to increase the capacity of the channel. An illustration of FDM is shown in figure 14.11. ASK analog signaling invokes combining signals of different colors with filters on the receiving end to separate them. The same technique can be applied to the light transmitted through a fiber optic cable. The process is called wavelength division multiplexing or WDM. Its name reflects the fact that light is usually identified by its wavelength, not its frequency. Both wired and wireless analog signals are particularly susceptible to noise and other forms of distortion. Signal loss can occur if there are taps or splitter along the channel. Amplifiers can be used to restore the original strength of the signal. Maintaining the high signal-to-noise ratio is important in maintaining the integrity of analog signal. See figure 14.12. In addition to noise, analog signals are susceptible to distortion of the waveform. The results from attenuation and phase shift that occur across the channel spectrum. The goal then is to design a system in which noise, attenuation, and spectral distortion cannot prevent recovery of the original data.
Everyone, since the last reporter discussed analog signaling, we will now proceed to the second type of signal, which is digital signaling. Digital signaling is a signal that represents data as a sequence of discrete values. It has a finite set of possible values that signals can be converted into, such as on or off pulses. On is represented as a number 1 and off is represented as 0. If the value is going down, it means 0 pulses. If it is going up, it has 1 pulses. In digital signaling has a particular method, and it is called Manchester encoding. It is a form of digital encoding in which data bits are represented by transitions from one logical state to the other. So here's the example of Manchester encoding. The state of a bit is determined according to the direction of the transition. As we can see, the transition here from low to high represents logic 1, and the transition from high to low represents logic 0. And we also have this alternative encoding methodology called block coding. It adds additional bits to small blocks of data. Block coding is often used to compensate for the shortcomings of other methods. Example here is the 4b over 5b. It will encode a 4-bit input into a 5-bit output, which eliminates the long strings of zeros. So we have here the 4b over 5b encoding table. For example, there is input data of type 0101, so we have to find that 1 in the 4-bit groups. So its transmitted code is 01011. Another example, as you can see here in our PowerPoint, there is a set of data that is also grouped in 4 bits. First is 0010 and its transmitted code is 10110. Next is 1010 input and 10110 transmitted code, and so on. And these transmitted codes are called output encoded strings. Now, let's proceed converting analog data to digital form. This way is called false code modulation or PCM. There are 3 steps in the process: sampling, quantization, and encoding. And the device that performs these three steps or process is called an A to D converter or analog to digital converter. So let's move on to the repeater, which is a network device through which you can boost the wireless signals. Because the signals in the networks often travel some distance, their intensity drops. So we go forward to division multiplexing or TDM. Different users' digital signals are transmitted over one link by dividing time into slots or intervals and assigning them equally among these users. In the center part, we can see the letters like the A, B, C, D that are traveling to the next users, and that is what we call the slots or intervals. So let's go to the last topic that I am assigned to discuss for today, and that is modem. So what is modem? Modem are what bring the internet into your home, and it maintains a dedicated connection to your internet service provider to give you access to the internet. Modems are very important because of the two different types of signals. Remember the two different types of signals that are used in a computer and on the internet. A computer only reads digital signals, while signals out on the internet are analog type of signal. So the modem is necessary for it to work in terms of providing internet to the computers. If you are wondering if a modem and a router are the same, well, the answer is no. Because the router is what routes or passes your internet connection to all of your devices. Technically, you don't need a router if you only have one devices to access to the internet. You can just plug the devices, or you can plug the device network cable directly into the modem, and then you can access already the internet. However, most of us having multiple devices, right? So that we need to access the internet with, and that's where you would need a router. In short, the internet will pass to the modem, and the modem will pass the internet to the router, and the router will pass the internet to the different devices that we have in our home. So that's all for my part.
So good day everyone. My name is John Eric Dumay, and I'm going to report about the transition media and signaling methods. So what is transition media? It means used to carry signal being transmitted from one location to another. Data may be transmitted using electrical signal on wires with light signals on fiber optic cable, or wirelessly using radio waves, or less commonly light or sound. It is characterized by physical properties, signaling methods, bandwidth, and sensitivity to noise. So there are types of transition media, which are the guided media and unguided media. The guided media is a transmission media that confines the signal physically to a cable of some kind, while the unguided media is a media that broadcasts the signal openly using radio waves, light, or sound. Unguided media do not confine the signal to a particular area, but the signal may be focused on a particular direction. Signal-to-noise ratio is the measurement of the noise in a channel in relation to the size of the signal. As the higher the signal-to-noise ratio for a given bandwidth, increases the data capacity of the channel. So there are the characteristic and general capabilities of each media type. So the first one is the electrical media. Electrically based media require a complete circuit consisting of two wires, one to carry the signal, most familiar to you from the electrical wiring in your house. It is referred to as wire media, or just wire, or sometimes copper, because most wire is made out of copper. It is inexpensive and easy to use. Signal carried as changing electrical voltage or current. So there are types of cable. So the first one is copper cable. And the copper cable has also two types. And the first one is the twisted pair. So the twisted pair, it is the most common electrical transmission medium. It is used for standard telephone and most local area network wiring. Twisted pair consists of two wires twisted together. Group of twisted pairs are frequently bundled together in a larger cable. There are a number of standardized types of twisted pair wiring. There are also some wire pairs that are untwisted. It is most susceptible to noise than coaxial cable. It also used for shorter distance and slower signals. So the other types of copper cable is the coaxial cable. Coaxial cable is a wire surrounded by insulation. It is a copper shield around insulation that acts as a signal return and a shield from external noise. It can be used for high-speed transmission of digital signal at the rate up to 100 million bits per second or even more. Coaxial cable are far less susceptible to noise than the twisted pair and is well suited for a relative long distance connection. So the other types of cable is the fiber optic. So the fiber optic cable consists of glass fiber thinner than the human hair. It also uses light to carry signals. It also has laser or light emitting diode produces signal. And cladding, it means that plastic sheet to cover fibers. So the advantages of fiber optic cable has a light waves that has high frequency means high bandwidth. It is also less susceptible to interference and tampering. It is also lighter than the copper cable. While the disadvantages of the fiber optic cable, it is difficult to use, especially for multi-point connections. So the last one is the electromagnetic wave. So electromagnetic wave is a transmission that not require a specific physical medium because it uses space as a medium. So microwave is the most common form of wave transmission. It means frequency below light but above 1 GHz. It is also called unguided medium. It is tightly focused for point-to-point use and highly susceptible to interference. Applications. It uses large-scale internet backbone channels, direct satellite to home TV, and IEEE or 802.11 Wi-Fi or wireless fidelity. So that's all my report about the transition media and signaling methods.
Good day everyone, I am Josiny Collins Indentia and I will be discussing alternative technologies and cellular technology. Let us first discuss what is alternative technologies. Alternative technologies are forms of technology that are used to replace the usual or current form of technology. Alternative technology includes wireless networking, which uses radio wave technology as a transmission medium. So let us focus on wireless networking. Wireless networking is categorized by range, the short range and the long range. Short range starts from local network. An example of this is wireless Ethernet or commonly known as Wi-Fi. On the other hand, long range or up to Internet includes WiMAX or cellular technology. Other examples of alternative technology include Bluetooth. Bluetooth is an example of generally accepted standard. There is also recent development of technology and standard to interconnect wireless Ethernet into wireless mesh network, which means that Wi-Fi can be linked to a larger network. In general, radio-based technologies show different and ingenious ways in which the techniques were combined and manipulated to implement the high-speed wireless communication that we now use every day. Now let's move on to cellular technology. Cellular technology refers to a network technology that facilitates mobile device communication over long-range areas. As what I have mentioned earlier, cellular technology is part of wireless network under long range, meaning it can reach not just locally but internationally all across the world. It is commonly used to facilitate service through initial cell phones. Now let us talk about initial cell phone. Initial cell phone was totally analog. Why? Because it became the medium for transferring messages from one person to another, which then makes it also an analog carrier, for it also serves as a medium for mobile voice telephony. However, analog technology was inefficient and it turns out that it needs mobile data communication. Due to this, analog cell technology quickly became obsolete or no longer useful. Analog telephony was then replaced by a number of incompatible digital cellular systems. This had caused radio frequency bands to differ from one place to another. Incompatible digital cellular systems turned out to be more inconvenient towards travelers, for when they travel to another places, they need to purchase another cell phone. During the fourth generation, long-term evolution or LTE, or commonly 4G LTE, emerged to address the problem being faced during analog telephony. LTE is based on a modulation technique called quadrature amplitude modulation or QAM. QAM is based on carefully tailored application of amplitude modulation and phase modulation. LTE or 4G LTE specifies 300 MB per second of downlink data rates and 75 MB per second in uplink data rates, which means that it could reach long ranges depending on the signal. QAM is also used for digital televisions, digital cable, Ethernet over power lines, and other applications. Going back to LTE, its QAM values range from 4 QAM to 256 QAM. The LTE systems was designed to self-optimize based on signal quality and given time. Therefore, if the signal is weak or buried in noise, LTE also slows down. As time passed, cellular technology also evolved. Today's generation, many cellular technologies already exist with various uses and are very convenient towards all the users. That's all about alternative technologies and cellular technology. I hope you learned something and thank you for listening.
Hi, this is once again Anamitsi Hinyoso. This sport should have been reported by Mr. Enriquez. However, he was not able to take part of this video because he had some emergency to be taken care of. So let's proceed to the last part of our report, which is the Wi-Fi and Bluetooth. So Wi-Fi is a short term for wireless fidelity. So Wi-Fi is wireless Ethernet. It is a short-range local area networking and is defined by IEEE standard 802.11. So there are several types or versions of Wi-Fi. As of this writing, there are known to be 802.11a, 802.11b, 802.11g, 802.11n, and 802.1 LAC. Although there are some degree of backward compatibility and overlap in design, each version has its own design specifications, its own ratio frequency bands, and its own modulation technique. So the most recent versions of Wi-Fi uses a modulation technique called the orthogonal frequency division multiplexing or OFDM. OFDM is a variation in this concept, and normally it is necessary to separate the different frequency bands completely. OFDM uses a number of different orthogonal subcarrier frequencies to carry the digital packets, and each of these packets is divided up among the various subcarriers. Each subcarrier is modulated using QAM or quadrature amplitude modulation or some form of PSK or phase shift keying. So the details differ for different versions of Wi-Fi, and OFDM is also used for WiMAX and for DSL or digital subscriber line data transmission service over standard telephone lines. WiMAX or Worldwide Interoperability for Microwave Access is a cellular telephone technology. It is the competing versions of longer range wireless networking. Meanwhile, Wi-Fi is an access point and it is a hub for wireless devices and a router between wireless and wired devices. It forwards packet to destination stations. We also have here the CSMA-CA or Carrier Sense Multiple Access with Collision Avoidance. It is a collision avoidance and not collision detection. Lastly, we have here the Bluetooth. It is a personal level networking that consists of one master node and up to 7 slave nodes. When connecting, the master node transmits an initial packet, and this case is called a frame, which provides for time synchronization for each slave. It uses time division multiplexing to schedule and control access to the network. Each time slot is 625 microseconds long, and an individual frame fills 1 or 3 or 5 slots starting from the time of connection. The master transmits frames starting with an even numbered slot. The slaves respond starting with an odd numbered slot, and slaves only transmit in response to a request from a master. In this way, there is no contention among the slaves for the slots. Bluetooth divides its frequency band into 79 channels, and each of successive frame is transmitted in a different channel assigned randomly by the master node, a technique called frequency hopping spread spectrum. So the purpose of this is to minimize the interference from other devices using the same frequency band, and it also provides a measure of security. The frames are transmitted primarily using FSK or frequency shift keying, although more recent versions of Bluetooth can also use certain types of PSK or phase shift keying. All for our report, and we hope you had learned something. Thank you for listening.
Once again, we are the Group 2 composed of our group leader, Ana Mitzi Ginyoso, the consolidator Alan Dre Escomedo, members Cindy Caddis, Kimberly Kedora, John Eric Domay, Joyce Nicole Incidencia, and Jerome Neil Enriquez. That would be all. Thank you for listening.